In this video, I will show you how to write the standard form equation of an ellipse, even if the center is not at 0, 0. Keep in mind that the standard form equation of an ellipse looks like this, where the center is h and k. Notice that there's always a 1 right here. So the first thing I need to do is pay attention to what the center is. So since the center is right here, the coordinates are 0, 2. That's going to give me the numerator for both terms of this equation. So I'm going to just have x squared. Because of the zeros, there won't be any x plus something or x minus anything. Unlike the y term, since I have this y value of 2, then I will have y minus 2 in this numerator, squared. So notice it's always the opposite. If this is positive 2, then I'll have a minus 2 here. If this had been a negative 2, I'd have a plus 2 here. Now, how about these denominators, a squared and b squared? Well, the a value and the b value are the distances to the vertices and the co-vertices. So these are the vertices. So notice that the distance here is 4. So that tells me that the a value is equal to 4. Alright, the a value is always the distance to the long way to a vertex. Now, since the a value is 4, that means that a squared is 16. Now, notice that this a value is in the horizontal direction. That tells me that the 16 will go with the x term, which is the horizontal direction. Now, the b value, and I'm just going to switch colors a little bit here. Alright, so the b value is the distance from the center to a co-vertex. So this is my b value right here. And that b value is 2. So since b is equal to 2, then b squared, of course, is 4. Now again, notice that this b value is in the y direction. So it won't be a surprise to you that this 4 will go in the denominator of the y term. So that's it for number 4. This is the standard form equation of the ellipse. Alright, let's take a look at number 5. So this time the center is -1, 2. So right away that tells me the numerators for both terms. So since the x value is -1, I'm going to have x plus 1 squared in the numerator. Since the y coordinate is 2, I'm going to have y minus 2 squared for that numerator. Now let's talk denominators. Let's start with the a value, which is always going to be the long way. So this distance right here is the a value, because this is going to be a vertex. So the a value is 3, which tells me that a squared is 9. Notice that this a value is in the y direction. It's vertical. So it won't be a surprise that I'm going to put this 9 in the denominator of the y term. Alright, similarly, here's the b value, the distance from the center to a co-vertex. It's the short way. And since this b value is 2, that means that b squared is 4. Because the b value is in the x direction, it won't be a surprise that this 4 will go in the denominator of the x term. And that's it. This is the standard form equation of the ellipse. Alright, for number 6, we are not given a graph. We are given an equation. This is not quite general form, but it's close to general form, and we just need to rewrite this in standard form. The main thing to keep in mind is that an ellipse always has a 1 here in standard form. It's always equal to 1. So I clearly must deal with this 225, and of course the way I could turn that into a 1 is by dividing by 225. So I will need to divide both sides of the equation by 225. So all we really need to do is reduce these fractions. How many times does 9 go into 225? Well, it turns out that 25 times. 9 goes into 225 25 times. How many times does 25 go into 225? You guessed it, 9 times. So when I rewrite this equation, what I have is x squared over 25 plus y squared over 9 equals 1. And that's it. This is the standard form equation. Alright, that was ridiculously easy, but this one is a little bit more of a challenge. We're going to have to actually complete the square this time. To do this right, we're going to have to match up terms that have the same variable. So we're going to group our x terms together, so keep an eye on that. And I've got these y terms that are going to be grouped together, and this 193 has got to get out of there. It's on the wrong side of the equation. Just get out of the way. Get out of my face. So grouping the x terms together, we've got 4x squared minus 8x. Those go together. And then the y terms, I'm going to have plus 9y squared minus 90y. And then we will have equals negative 193. Alright, now that we've grouped the x terms together, because we have this leading coefficient, we need to factor that outside of parentheses. So that's going to look like this. We'll have x squared and then minus 2x on the inside. Now go ahead and leave space to complete the square. I'm going to leave a little empty space there. And now I'm going to do the same thing with the y terms. I'm going to factor out that 9. So if I pull this 9 out front of parentheses, inside the parentheses I will have y squared minus 10y. And again, leave a little space here to complete the square. And that's equal to negative 193. So now, in order to complete the square, we do half of the middle, and then we square that. So half of the middle here is going to be negative 1. If I square that, I'm going to get positive 1. So I'm going to put a plus 1 here. Now I need to balance that out on the other side of the equation. You might think I would add 1 to the right hand side, but you'd be wrong, because this is not really a 1. This is really 4 times 1, so I need to add a 4 to the right hand side to balance it out. Alright, similarly, to complete the square with the y terms, I'm going to do half of the middle squared. So half of the middle is negative 5. Negative 5 squared is positive 25, so I'm going to put a plus 25 here. However, on the other side, I need to do 9 times 25. That's 225, so I need to add 225 on the right hand side to balance this out. Okay, so now I can go ahead and factor. So here I will have 4 times, and this is going to factor as x minus 1 times x minus 1. The whole point of completing the square is making it so that it will factor as the same thing twice. So this is going to factor as y minus 5 times y minus 5. If the middle term is negative, when you factor, it's going to be negative. Alright, now I need to add up these three numbers. That turns out to be 36. So because this is the same thing twice, I can go ahead and write 4 times x minus 1 squared plus 9 times y minus 5 squared is equal to 36. Now remember, we are shooting for the standard form of an ellipse, so we should definitely have a 1 on the right hand side of the equation. Right now I have a 36, so I can fix that by dividing both sides of the equation by 36. So now it's just a matter of reducing these fractions. Of course, 4 goes into 36 9 times, so I will have x minus 1 squared over 9. 9 goes into 36 4 times, so I will have y minus 5 squared over 4, and equal to 1, just like we wanted. So this is the standard form equation of the ellipse. Now this problem is very similar to the last problem, so please pause the video and try to do this problem by yourself. So I need to group the x terms together, and I want to group the y terms together. Alright, and I need to put the plus 16 to the other side. Whoops. Alright, I need to move the 16 to the other side of the equation. So grouping the x terms together, I'm going to have 25x squared plus 100x. Now grouping the y terms together, I will have plus 4y squared plus 16y. Moving the 16 to the other side by subtraction, I will have equals negative 16. Now I need to factor the leading coefficient outside of parentheses. So I'm going to take this 25 and put it out front, so I will have x squared plus 4x, and I'm going to leave space here to complete the square. And then I'll do the same thing with this 4, factor it out of the parentheses, so I will have y squared plus 4y, leave some space to complete the square, is equal to negative 16. So half the middle squared. So half of this is 2, and then if you square that, you're going to get 4. So I'm going to get a plus 4 here. Now I need to balance that out on the right hand side, but this is not a 4. This is really 25 times 4, so I'm going to balance it out with a 100. Now, for the y terms, I will again do half the middle squared. So again, half of this is 2. Square it, you get 4. And again, I have to balance this out. But this is still not a 4. This is 4 times 4. So I'm going to balance it out with a 16 on the right hand side. So now I can factor. Again, the point of completing the square is making sure that it factors as the same binomial times itself. So this is going to be x plus 2 times x plus 2. And this will be y plus 2 times y plus 2. Okay, I need to add these three numbers together, but it's pretty simple when you see that the negative 16 and the positive 16 cancel each other out, and I just have 100. Okay, so because this is the same thing twice, I can write this as 25 times x plus 2 squared plus 4 times y plus 2 squared is equal to 100. For standard form, we need equals 1 on the right hand side. So we will divide by 100 to get the 1 that we're looking for. And we need to divide both sides of the equation by 100, which really just boils down to reducing these fractions. 25 goes into 100 4 times, so I will have x plus 2 squared over 4. 4 goes into 100 25 times, so I will have y plus 2 squared over 25 is equal to 1. And this is the standard form equation of the ellipse. Again, number 9 is almost the same, so try to do this problem by yourself. So I need to group my x terms together, so I've got those. Now I've only got the one y term, so there's nothing to group it with. I'm still going to need to move this negative 216 to the other side by adding it to both sides. So my x terms together, I've got 9x squared plus 18x. And then I'll put my lonely y term, so plus 25y squared, and that's going to equal positive 216. This 9 needs to be factored outside of parentheses. So I will have 9 and then x squared plus 2x, leave space to complete the square, and then I will have plus 25y squared. When you just have a single term, there's no need to complete the square. It's already a perfect square. But for the x terms, I will need to complete the square. So half the middle squared is how we do that. Half of this is 1. 1 squared is still 1. So I'm going to put a plus 1 here. I need to balance that move out by adding something to the right-hand side, but I will not add a 1 because this is really 9 times 1. So I'm going to add 9 on the other side. So factoring this trinomial, I have 9 times x plus 1 times x plus 1, and then plus 25y squared is equal to okay, so I can write this as 9 times x plus 1 squared plus 25y squared is equal to 225. Alright, again, we always need equal 1 on the right hand side, so I need to divide both sides by 225 to get that 1. Alright, so essentially I need to reduce these fractions. 9 goes into 225 25 times. So this is going to be x plus 1 squared over 25. 25 goes into 225 9 times. So I will just have y squared over 9 when you reduce this fraction. And of course this equals 1. So that's it. That's the standard form equation of the ellipse for problem number 9. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.